if you like.
Sure. It should have gone through it. I just sent it.
Uh,
Okay. How's your day so far?
Good. I was really happy to be able to figure out how to do this problem. There's the formula you have to memorize.
Okay.
And what it means by a probability distribution is what is the probability of all possible outcomes.
Okay.
In other words, if we do W there and probability there, and
Hmm.
there are 6 possible outcomes. You can win 0 games, you can win
Okay.
1, you can win 2, you can win 3, you can win 4, or you can win 5.
Hmm.
And what goes in the P below the 0 is this, where N is always 5 and R is whatever is the win.
Hmm.
Okay. So what would go right there would be 5, choose 0,
Hmm.
because this is 0 wins,
Yeah.
times the probability of the win. Well, to the R is to the 0, times the probability, or 1 minus the probability, which is the probability of the loss.
Hmm.
And N minus R, for this case, is to the 5th.
Okay.
Okay?
Uh-huh.
And each one, in other words, whatever that number comes out to be, that's the answer. And if you think about it, first of all, 5 choose 0 is 1.
Right.
Okay?
Okay.
Point 0.7 to the 0 is 1.
Hmm.
So what this would require is for the Rockies to lose 5 straight games, right?
Right.
And that would be zero point 0.3 times zero point
Hmm.
0.3, or, times zero point 0.3 times zero point 0.3 times zero point 0.3.
Right.
So that's zero point 0.3 to the 5th power.
Okay.
And that is what goes in that slot right there.
Okay.
And to do exactly 1 game,
Hmm.
that becomes a 1,
Hmm.
that becomes a 1, and that becomes a 4 because it's N minus R.
Okay.
So whatever number you get for that goes in that spot.
Okay.
And then for 2, that becomes a 2, that becomes a 2, and that becomes a 3,
Hmm.
and so forth and so on. And by the time you get to the 5th spot, well, then that's going to be 5 choose 5, which is also the number 1,
Hmm.
times zero point 0.7 to the 5th power times zero point 0.3 to the 0. Well, this is 1.
Okay.
That's 1. That would be zero point 0.7 to the 5th, which is exactly what would have to happen. They would have to win 5 games in a row, and their odds are zero point 0.7 to win any given game. So
Okay.
the odds of them winning 5 in a row would be zero point 0.7 to the 5th power.
Okay.
But that's easy to figure out. That's easy to figure out. That's easy to figure out. And that's easy to figure out. These are the
Okay.
2 hard ones right here.
Hmm.
That one and that one are really the only ones that require you to use that formula.
Okay.
Okay? Any
Hmm.
of the other spots you could do like we did. In other words, the odds of winning 5 in a row are zero point 0.7 to the 5th. I don't need that
Okay.
formula for that.
No.
And the advantage of this formula is it would work on any combination. In other words, if you had 15 games and you wanted to know the probability distribution, you would have to use this formula and calculate it for each spot. In other words, if it was for 15 games, then we'd need 0 wins through 15 wins and the odds of each one of them. Now, what else do we know about that square, that square, that square, that square, that square, and that square? What's it got a total?
1.
Exactly. Always, because those are the only 5 possibilities. They can either win 0, 1, 2, 3, 4, 5. Now, you don't have to use a table here. You can use a bar chart where this would be 0, that would be 1, 2, and so forth. And this would be the probability up there. And the probability of winning 0 would be really low. Probability of winning 1 would be even, a little better, but not as low as winning 0, and so forth. And you'd end up with a bar chart instead of a table. Okay? And figure 1 is a probability distribution. And these probability distributions can be discrete, like this is, or they can be continuous. They don't have to be discrete. If they're discrete, then you're going to use individual bars. But if they're continuous, you're just going to have a curve. And a lot of times, it'll be a normal shaped curve.
Right.
In other words, if the Rockies were only won exactly 50% of their games, then the curve is going to look a lot more like that. The way I drew it as a bar chart, it's skewed a little bit, and that's because the Rockies win 70% of their games. In other words, it's easier for them to win 5 in a row than it is to win 0 in a row.
Okay.
Or 0 out of the 5. Much easier. So this end is going to be taller than that end. And it wouldn't be normally shaped. But typically it would. If they won at 50%, then that is going to be the same odds. Winning either 2 or 3 would be exactly the same.
Right.
But this is the key formula you have to memorize. That is the probability distribution formula.
Okay.
And you have to know how to do these combinations, N over R. You might also recognize this. That is the same exact thing as the binomial distribution. In other words, when you take A plus B and you take it to the n power, you get something that looks very similar to that. Plus another term, in other words, plus that term, plus that term, plus that term, and so forth. But that's why this probability distribution is so important. And that's why I felt the need to really go through it with you.
Okay. Yeah, no, that's good.
Actually, that I didn't know it yesterday. I had read it. It's just when it's been a year since you read something, you don't recall it instantly.
Right.
So,
exactly what you mean.
Do you try sending me something again?
Yeah.
Let me have a quick look.
Should have gone through. Okay.
Yep.
Cool.
Which page? Again, no
let's do.
So we got 20 minutes.
Yeah, let's do the first page. We can do the first page. And then we could start on number 5.
Okay. Again, if I had these in advance, I would have been able to work them out.
I know that's on me. I thought it went through. Like it said it went through. I sent it during math actually.
Oh, okay. All right. Well,
Because
here,
again,
I might be able to figure this one out anyway.
okay, my phone's been really screwed up lately. Like texts and emails aren't going through, and battery issues. I need to get that fixed. That's on me. I apologize for that.
Okay, 5 is relatively straightforward.
Mm-hmm.
Keyword on 5. Hold on a second.
Okay.
Do this a little different.
Mm-hmm.
Not that. There we go.
Cool.
Keyword on. Oh man, I hate this program. Doesn't cooperate very well. Is this one right here?
Okay.
Independent of each other. Okay.
Mm-hmm.
So, test A has a 90% probability of being positive if steroids have been used.
Mm-hmm.
That means it has what percent probability of being negative if steroids have been used?
10%.
So negative and steroid
Mm-hmm.
equals 10%.
Okay.
And positive steroid.
Right.
Okay.
Okay.
Test B has an 80% probability of being positive if steroids have been used. So the chance that it's negative and steroids were used would
Mm-hmm.
be 20%.
Right.
Okay. Now,
Okay.
what's the probability that neither test is positive, which means negative and negative,
Yeah.
if steroids have been used, which means
Okay.
positive and positive? Well, that would have to be true, and that would have to be true. So what do I do to those two numbers? When two things both have to be true and they're independent of one another, you
Just multiply them together, right?
multiply.
Okay.
And there's one really easy way to test it.
Okay.
Flipping a coin.
Uh-huh.
Okay. If you flip a coin twice, and
Okay.
you want to know what's the odds of getting two heads.
Mm-hmm.
Well, the first time you flip it, it's 1/2 of getting a head.
Right.
Second time you flip it, it's 1/2 of getting a head. So
Okay.
to get both heads, you multiply those two and you get 1/4. And
Uh-huh.
that makes sense. It's not going to happen very often. And in
No.
fact, here's the 4 ways you can flip a coin. You can
Mm-hmm.
flip head head. You can flip
Okay.
head tail. You can
Right.
flip tail head. And you can flip tail tail. There's
Mm-hmm.
4 ways. There's only one way out of 4 that it's head head.
Right.
Okay. So using this simple little thing that you can always figure out, then you will never make the mistake of adding these instead of multiplying.
Mm-hmm.
You don't want to add 1/2 to 1/2. For one
No.
thing, that gives you 1, which would
Right.
be impossible. You're not going to have 100% probability that neither test is positive if steroids have been used. That wouldn't make
Mm-hmm.
sense that it could
No.
possibly be 100%. And
Right.
usually on these probability questions, it comes down to whether you should multiply or whether you should add.
Okay.
Okay. So,
Okay.
all right. So that one's relatively straightforward. The only problem was I don't see that answer on there.
It's 0.02. Yeah.
Yeah. I'm sorry. I was using
No,
my
you're
example. I was looking for 0.25. No,
good. No, you're
yeah,
fine. You're fine.
0.1 times 0.2, which is 0.02. Okay.
Mm-hmm. For sure. No worries.
All right. Number 6. I think I can do that without scrolling down.
Okay.
Okay, it's estimated 60% of registered voters actually vote during a non-presidential election year, like this year.
Mm-hmm.
However, in a presidential election year, like 2020, 85% will vote. Okay, so what's the probability of each of the following occurring? Among 5 randomly registered voters, at least one will vote in a presidential election year.
Would you do 1 minus, in parentheses, 0.15
This
to the
is
fifth?
where you use that formula.
Okay.
Pretty cool.
Mm-hmm.
Let me write the formula again.
Okay.
Okay?
Mm-hmm.
So, among 5 randomly selected voters. So what's N and R going to be? At
And
least
R.
1 out of 5. R always has to be smaller or equal to N.
Okay.
So it's got to be 5 chosen 1.
Mm-hmm.
5 choose 1. In other
Okay.
words, we're at least 1. So
Oh, yeah.
actually, this is going to be right. In other
Mm-hmm.
words, at least 1 means 1, 2, 3, 4, or 5.
Right.
At least 1 will vote in a presidential election year. Okay.
Uh-huh.
So we have to do this calculation. There's probably, there would be a slightly easier way to do it. Let's think about this for a second. Well, first of
Okay.
all, it's worth knowing. I believe you're going to have to know that for your test.
Yeah.
All right, so make sure you memorize it.
Okay.
And P is 85% or 0.85. Okay.
Uh-huh.
So if I do this one alone, I won't bore you with the math on all 5,
Oh,
but
you're good.
this one alone, it's going to be 5 choose 1, and that incidentally is 5,
Mm-hmm.
times presidential year, so we're using 0.85 as our probability of voting,
Mm-hmm.
to the 1 power.
Okay.
And this one is 1 minus the probability, so this one's going to be this one. And this is to the 5 minus 1 power.
Okay.
These 2 exponents always have to add up to 5.
Yeah.
Okay? And
Okay.
that would be the probability that precisely 1 will vote.
Mm-hmm.
Then we would have to do the same calculation for that, for that, for that, and for that, and we would add all of those together.
Okay.
Okay?
Okay.
But I think there's an easier way to do it.
Okay.
Let me think for a second. If we figured out the probability that nobody votes,
Mm-hmm.
that is the what's it called? The counter. In other words, 1 minus this probability would have to represent everything else.
Right.
In other words, if I add all 6 of these, I know that has to come to 1,
Mm-hmm.
right?
Okay.
So
Right.
if I figure out just that one there,
Mm-hmm.
then I can subtract that from 1, and that will give me the sum of those 5. And it'll be much quicker.
Uh-huh.
Okay, so let's do it. It's 5 taken 0 at a time, which is the number 1.
Mm-hmm.
Remember, it's n factorial over n minus r factorial times r factorial. So that's
Right.
the number 1.
Okay.
And then it's 0.85 to the 0 power, because it's
Uh-huh.
r.
Yeah.
And then it's 0.15 to the 5th power. Well, that's the number 1. Anything to the 0 power is the number 1.
Mm-hmm.
So it's 0.15 to the 5th power, and it's 1 minus that.
Yeah.
So it's 1 minus 0.15 to the 5th power.
Mm-hmm.
And that's much easier than the original way we were doing it,
For
where you
sure,
have to
yeah.
calculate each of the probabilities of each of those 5 and add them together. Instead, just calculate the probability of that one and
Mm-hmm.
subtract it from 1.
Okay.
Okay?
Cool.
Now let me erase some of this stuff
Okay.
so that I can see what they want for part B.
Okay.
I don't want to erase this one though. In other words, I want you to memorize that, and the longer I keep it up there. So, you want me to put this answer, 1 minus 0.15 to the 5th power?
Yeah. I got
Um,
that.
Now, you can always access the recording of this.
Oh yeah, for sure. Okay.
So that's the answer to A.
Mm-hmm.
That was tricky. Not
Mm-hmm.
really. Not if you base everything off of that. I mean, it was a
Right.
little tricky being able to do it in a shortcut.
Uh-huh.
Had they said precisely 1, then
Mm-hmm.
we would have just used 5 taken 1 at a time,
Exactly.
and whatever that probability would be. Okay,
Mm-hmm.
among 10 randomly selected voters, all will vote in a presidential election year. So tell me
So
what that should be.
you would just do 0.85 to the 10th.
Yeah, which is the same as this.
Uh-huh.
And
Exactly.
I want to do it this way just to show you that it's the same.
Okay.
Remember, the 0.85 is to the r power,
Mm-hmm.
and the 0.15 is to the n minus r.
Mm-hmm.
Again, 10 chosen 10 at a time is 1.
Right.
And that is 1. So that's how you end up with 0.85 to the 10th power.
Mm-hmm.
Even though you knew intuitively that it had to be 0.85 to the 10th power.
Right. Yeah.
Still, being able to use this going to answer a lot more questions for you than intuitively doing it.
For sure.
All right, I'll go ahead and put that on there.
Okay.
Among 10 registered voters, at least half will vote in the non-presidential election year. Amongst 10, at least half. So that is going to be
Greater
5,
than
6, 7, 8, 9, or 10.
right. Yeah.
So, and I don't know whether we can make this a shortcut. And this is a non-presidential election year.
Mm-hmm.
So it's that. That's precisely 5.
Mm-hmm.
And I'm going to add to that 6. Get where I'm going here?
Where did you get the 65%?
Oh, 60%. Excuse me.
Oh, okay, okay. I was just making sure I
Oh,
wasn't missing
thank you.
something.
I had made
Yeah,
a
no, you're
mistake.
good.
So that's 60
No.
and that's 30.
Okay.
60, 40, excuse me.
No, you're good.
Yeah, I just add two numbers to 10. I'm fine. Um, let's see.
No, you're good.
So, yeah, and then that's to the fourth power. Remember,
Hmm.
that power is always r, which is that one, and this
Right.
power is always n minus r,
Uh-huh.
okay? And then you would
Okay.
add to that 10 taken 7, all the way down to 10 taken 10.
Okay.
You would add those 6 possibilities up, because that is 6 possibilities,
Uh-huh.
and whatever they add to, that's the answer, because at least half means 5 works, 6 works, 10 works. Now, I don't see a shortcut at all for doing this. I'm
Hmm. Yeah.
trying to think.
Well, we know this is a binomial equation.
It uses the binomial equation, but it also uses the probabilities, which the binomial doesn't use. But the binomial actually has something extremely similar to this. If you look up the binomial equation, you'll see something virtually exactly like that. Only
Right.
it's plus, 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 and then the next term is n over r minus or r plus 1 or something like that.
Mm-hmm.
I'd have to kind of look it up, but it looks a lot
Very good.
like this.
Okay.
And that's because what we're talking about is combinations here.
Mm-hmm.
In other words, how can we select 5 people out of 10? Or how can we select 6 out of 10? How many ways
Right.
are there to select that? And so it ends up always being combination problems because you don't care the order.
Uh-huh.
You know, at least half, it could be
Right.
different 5 people. It doesn't have to be the second half of the 10 registered voters.
Mm-hmm.
Um, so it's a combination problem, not a permutation problem.
Right, right.
Well, I gotta go. Hopefully
Sure, yeah.
this was helpful tonight. Just
Oh, it was really
remember
helpful. Oh, yeah.
that works on pretty much every situation. Now that'll
Okay.
only give you one. You know, when
Right,
they
right.
give you questions at least half, well, then you got to consider 10-5, 10-6, all of them.
Okay.
If they'd
Okay.
have said exactly 5,
Mm-hmm.
then your answer is going to be that.
Uh-huh.
But they said exactly 5 or exactly 6 or exactly 7. So there's
Right.
an or there. And so the other thing to learn is that when you see the word or, you're adding probabilities.
Mm-hmm.
When you see the word and, you are
You,
multiplying probabilities.
okay.
If I have to flip a heads on the first roll and a heads on the second roll, I'm multiplying 1/2 times 1/2.
Mm-hmm. Okay. Cool.
And or is, well, that's more complicated, which I don't have time to explain right now. So,
For sure.
Dylan, good luck on your test.
Yeah, thank you.
You're
Cool.
welcome. Talk to you later.
Sounds good. Thanks, John. Appreciate it. All right, bye-bye.